Okay, this lesson is working with dilation. So a dilation is a transformation in which a figure is made either larger or smaller with respect to a point called the center of dilation. Okay, so dilation is going to be where you've got a similar triangle, but it's going to change in size. The shape is going to stay exactly the same. So we're going to work on identifying right now. One thing that to me was kind of confusing about the definition was the center of dilation. So they've done a really nice job here of showing us a picture. If we were to take our figures and have them facing the same direction, and we were to connect points, the same points from those corresponding points, they should end up meeting at a center. So you would pick 2 points and connect those 2 points. So for example, if I were to do letter A, I could connect this point and that point to these 2 points, which are my corresponding points on the other triangle. So if I do that with a straight edge, they should come to a center where they intersect. So take note, they intersected right here. Now granted, I have one of my lines that's a little bit longer than the other, but that is where they end up intersecting. So there, they have a perfect center of dilation. They came to a focal point, in other words. So these would be, we could also take one from this point too. You'll notice they did that on this example there. But these 2 figures would be considered a dilation of each other because they are the same shape. And by going through and doing that, we are proving with that visual effect that they are similar figures. Okay, so that their sides are going to be proportional. Okay, so looking at B, if I've got those 2 figures, if I were to go through and actually connect corresponding points, so this point to this point, and just extend it out. Making sure that it cuts through each of those. Okay, so this point would connect to this point. And then this point here would connect to this point. They should come to a center of focus. And you'll notice, once again, they don't. Even though they shifted these, offset them, they still don't come to a center focus where they end up intersecting as a focal point. So this would be, no, these would not be dilations of each other. They are actually, that shows a translation where they're the same shape and the same size and they're just slid one direction. So dilation is going to be where they just enlarge in size. Okay, so let's practice a little bit of these. Get rid of my extra lines and stuff here. Okay, so let's look at a couple other ones. So dilation is a change in size. So when we look at number 1, it looks to me like they're keeping the same size, looks like the same shape. So it did not change in size. Looks to me like they flipped it over. So they've taken it and they flipped it over that red line there. So this actually would be a reflection. Okay, in order for it to be a dilation, it's not that it can't move, because yes, we can have where one is slid one direction just to show a comparison. But in order for it to be a dilation, it has to be the same shape, but one that's enlarged. So yes, they will still be proportional. So here I have squares. And one thing we know about squares is their sides are always going to be proportional no matter what the side length is. And they always have right angles. So we know they're similar. We just need to figure out whether or not it shows a dilation of the red figure. And yes, it does. This is an enlargement of our red figure. So this would show dilation. Okay. All right, so we're going to work a little bit more. It says in dilation, the original figure and its image are similar. The ratio of the side lengths of the image to the corresponding side lengths of the original figure is a scale factor of dilation. So you guys worked a little bit with this when you guys were doing similar figures. Similar figures actually are dilations. Okay, in order for a set of figures to be similar, they have to be the same shape, which means their angles are always going to be equal, but their sides don't have to be equal. They have to be proportional. So when we worked proportions in a previous section, we would go through and check and say, okay, so if we had pulled two side lengths off of our image and wrote them out as a ratio, in order for them to be proportional, we could check our cross products, and if they were the same, or our decimal, if they were the same, then they would be considered proportional as long as they were the same shape, right? Okay, so that's what this lesson is going to be doing, only instead of them giving us the figures, we are going to create the figures. So we're going to use a scale factor to do this. So it says to dilate a figure with respect to the origin, multiply the coordinates of each vertex by the scale factor k. So what does k mean? Well, k, it stands for a constant. So we're going to pick a number, and then just like we did in our activities, we are going to take that number and multiply it by our x and by our y. So this is kind of what we already did in our activities. They're just having us extend on that, okay? So they just wrote it up differently. Notice here we still have x and y, but they put a k in there. They're saying we're gonna pick a number. So like in our activities, we took it times 2 and then times 3 in activity 2. Well, here, if we do a dilation or an enlargement, we're going to use a number larger than 1. And if we want to reduce or make one smaller, we're going to use a number smaller than 1, but yet greater than 0. Okay? So I know that part seems kind of confusing, so it's just easier to go through and actually practice it. All right, so this is going to be very similar to what we worked with in our activity. So here we have our figure, and the coordinates are set up over here on the side as 1, 2, 2, 2, and 2, 0. So we're going to go ahead and pick a scale factor, and they picked it for us. They want us to use a scale factor of 3, which means we're going to go ahead and multiply each of these by 3. So if I take 3 times x, this is what I'm doing. Okay, that's my first set of coordinates. Notice my x was 1. And then I'm going to do comma 3 times 2. I like to put my multiplication in a parenthesis. I know it kind of looks confusing, but now if I do 3 times 1, that gives me 3. And some of you will be able to bypass this middle set. 3 times 2 is 6. So 3 comma 6 is going to be my new coordinate. Okay, so then if I take each of these by 3, so 2 times 3 and 2 times 3. So I'll go ahead and write them out that way. It seems a little less confusing to do it that way. So 2 times 3 is 6 times 6. Okay, now I'm going to put these coordinates in there. So 2 times 3 again, and 0 times 3. Now the order, I know that I'm kind of reversing it here. The order is not going to matter. Remember, when you multiply, order doesn't matter. But the order in which I put my coordinates does. It has to be my x first and then my y. So I get 6, 0. Okay, so I'm going to go over to 3, up to 6. Over to 3, up to 6, put my dot. Over to 6, up to 6, put my dot. And over to 6, stay at 0, put my dot. Connect these. Okay, there's my triangles. They are similar triangles. They're the same shape. It's just one is larger or 3 times larger than the other one. So blue is 3 times larger than the red triangle. Okay, so we're going to go ahead and practice that again. We'll pick a different one. So this time our scale factor is 0.5. Okay, so we should end up with a figure that's smaller, because this is going to be less than 1. We should end up with a figure that's smaller. So I'm going to do 0.5 times my x was -4. And then I'm also going to do 0.5 times my y was -6. So if you're not comfortable with multiplying, this is where you can go ahead and use a calculator if you need to. 0.5 is the same as half. So half of -4 would give me -2. And half of -6, or 0.5 times -6, would give me -3. Okay, if you need to use the calculator, go ahead and do that. So my next set is going to be 0.5 times negative 4 again, and 0.5 times 8. So now if I solve those, 0.5 times negative 4 is negative 2. 0.5 times 8 gives me 4. 0.5 times 4 and 0.5 times 8. So 0.5 times 4 is 2. 0.5 times 8 is 4. And my last set, 0.5 times 4 and 0.5 times negative 6. 0.5 times 4 gives me 2. And 0.5 times negative 6 gives me negative 3. Once again, not comfortable with integers, pull your calculator out. I'm not checking your ability to work integers in this lesson. I want to see that you can enlarge and reduce a figure. Okay, so I'm going to go ahead and draw this triangle in blue, or not triangle, this rectangle in blue. So my coordinates over to negative 2 down to negative 3. There's my first dot. Done. Okay, my next one is over to negative 2 up to positive 4. Over to negative 2 up to positive 4. So this was my W. This was my X. Over to 2 up to 4. There's my Y. And over to 2 down to negative 3. Oops, I have 2 X's there. This should be a Z. Okay, so this is going to be a Z. Okay, so now when I look at that, and that's a horrible line. Sorry, I got off there a little bit. We can see that that was a reduction from the bigger red triangle to this, not triangle, rectangle to the smaller rectangle. We reduced, and we could tell that right away because this was less than 1, our scale factor was. Okay, so I want you to go ahead and try this one. Okay, so this time your scale factor is going to be a 2. And I gave you the same coordinates as the previous one. Now, some of you won't need this middle section because you'll go through and just multiply in your head. And some of you need to go through and actually see it. So go ahead and pause your video and work your way through this part of the lesson. Okay, so you should have ended up with the coordinates that are stated on the right side there. Notice I did not use the middle because I could, in my head, take each of these numbers times 2 without having to write it out. So the writing out is not required, but it is something when you're first learning that you might need to do. My triangles are similar triangles. It's just a scale factor of times 2 or an enlargement of 2.